All right, today we're going to take those fractional exponents and solve equations with them. So just as a reminder, take a second and see if you can solve these guys. All right, so this is me solving these. Some of you may want to pause it a second just to take a look, but the basic idea is if you have something squared, as long as the squared's by itself, you can take square root of both sides. And x, remember, it's plus or minus. You always have to take the positive and the negative for that one. Because negative 2 squared is the same as positive 2 squared. Same deal for here. If you have a square root, you square both sides. Now, maybe you don't recall that, but it's, just the opposite of this one. Okay, they're inverses of each other, so they undo each other. Just like when I do here, I have subtraction, addition undoes subtraction, and division undoes multiplication. That's the inverse. So the inverse of x squared is the square root. And remember, we have to do plus or minus, and I reduce this radical 12. Again, here, I just got 36. So that's the same idea with fractional exponents. Remember, radicals and fractions are basically the same thing. It's just a notation to represent that radical. So now when we do this, allow me to show you, instead of changing it to a radical, what we can do is just flip this exponent. And when I flip at the exponent and I raise this side to 2 over 1 and raise this side to 2 over 1, what happens is I get 2 over 2, which is x to the first power, which is what we're looking for. And then this is just 3 squared, which is 9. So it's basically the same as the second one on that beginning warm-up kind of activity. So that's what we want to do. Our basic idea is we want to get rid of this exponent. And if I realize that the reciprocal of that exponent, if I multiply this together, it's 6 over 6. And x to the 6 over 6 is the same as x to the first power. That allows us to get x by itself so that it doesn't have that weird fractional exponent. So then this is 9 to the 3/2 power. You literally just put this in your calculator. Since I don't have a calculator simulator here, you do this, or you use your alpha y equals, and you should get, in this case, 27. Now, we have to realize here, now you remember this number, the number that's on the bottom is always your index. And if your index is even, any even index, just like a square root is an even index, it's 1/2. We need to take the positive and a negative. So anytime you have an even index, you know that it's an even, you're taking the square root. You have to deal with the positive and the negative, okay? But it's not just square root, it's also 4th root, 5th root, etc. So this is the steps into solving this. Isolate. Now, this is the key to anything. Whenever we solve any sort of equation, we always have to isolate the weird thing first. So in this case, we remember before we isolated the absolute value. Now we have to isolate the power. The thing with the exponent needs to be isolated. If we have a radical, probably changing it to an exponent is best. Raise both sides to the reciprocal exponent. That just means flip it like I did. Solve, and then checking is probably a good idea. This is your reminder. If you have an even denominator, you must include both roots. Plus, that means the plus or minus thing. Okay, so I didn't check in the previous examples because they were just running. So now let's get to the nitty-gritty, and we'll do all the pieces. So you have to ask yourself, what is being raised to the 2/5 power? Is it x? Is it 2x? This is the most important question you can ask yourself. It's the difference between getting it right and not getting it at all. Okay, there are no parentheses. Notice there's no parentheses anywhere here. So that means that 2/5 is only going to that x. And that's the key to doing all of this. After that, it's pretty straightforward. So I have to get rid of that 2. And now that x to the 2/5 is isolated, it's by itself. So I need to take it, flip the exponent, 5 over 2. That goes away, and I am just left with x equals 16 to the 5/2 power. So we have to raise that to the 5/2 power. Okay, when I do that, I get 1,024. At this moment, the moment you just put this mess in your calculator, you have to ask yourself, is the denominator even? Is the index even? And it's a 2, so it is, so you must plus the plus or minus. It's at that moment when you're putting it in your calculator, so just please be aware and try to make that stick in your head there. So here, the x to the negative 4 is isolated. It's all by itself. So all I have to do is flip the exponent. Remember, that's negative 4 over 1. So it's negative 1 over 4 when I flip it. No sign changes, because we want, when we multiply these two together, we want that to be a positive 1. So we couldn't do that if we changed their signs. So x equals 16 to the negative 1/4 power. Put that in your calculator. Please make it a fraction. I guess 1/2 really isn't that deep of a fraction. 0.5 would probably be okay. But just remember, if I don't tell you where to round, don't. Leave it as a fraction. Then at that moment, I just put that in my calculator. That guy is even, so I got to put plus or minus. Okay? All right, for these, I did forget, so let's put the check back in here. So we should always check in the original. And this, okay, so I'm checking. Sorry, see, check. So for this one, I should have checked both 1,024 and negative 1,024. So it's 2 times 1,024. It's the 2/5 power. Does that equal 32? Plug that all into your calculator, and it does work. And then we do the same thing with the negative. And that equals also. So we have those two answers. So then you do the same thing here. You must check both of them. So let me just take a second and do that. All right, so here are the two checks. And we just have to plug them both in. I did this one and this one for the negative and the positive. Here we are. Now we have a radical. So what we need to do, we could square both sides, but I do want to show you that if you have a weird little fraction, a weird little radical, changing it to an exponent will allow us to solve all of these in the exact same way. So what you have to remember is that whole thing is in the fraction, or in the radical. So what we have to do is make that a fraction. There's nothing there, so it's a 2 for the index. The 2 goes on the bottom. And it just becomes another one of these. So then all I have to do is flip my exponent. 2 over 1. These cancel themselves out, and I'm left with x plus 2. Sorry, my stylus isn't exactly good. And then 6 squared is 36. I asked myself, is this even? No, so it stays 36, and I just solve whatever equation shows up. So subtract my 2, and x is 34. I should go and check this. So when I put this in, I really hate checking. I'm sorry, but you really need to. I have issues with checking. Even though it's probably the best thing you could do, but 36 equals 6. So 6 equals 6, check. All right, let's solve this one. Remember, what is being raised to the 4th power? These parentheses mean this whole thing is being raised to the 4th power. So it's isolated. We're all set. So all I have to do is flip my exponent. 1/4. Remember, 4 is 1/4. Now some of you can take the 4th root, and you know what that means, and that's fantastic. Otherwise, it's as simple as flipping the exponent for every possible equation that you solve. So I just put this mess into my calculator right here, and I got 2. Now, since I got 2, that's great. I have to ask myself, is this even? Yes, it's even. So that's the moment. I don't wait till the end to put the plus or minus. I have to do it then. So this is very similar to an absolute value equation at this point, because I have to set x minus 2 equal to 2 and x minus 2 equal to negative 2 and solve. So x equals 4. And x equals 0. So just take a second and check those and let me know if they work. Yay, they worked. Woohoo! Okay, now we get some little funky ones. But the key to doing things like this is just realizing what is being raised to the negative 4/3 power. It's the first question you have to ask yourself. And then once you do that, you isolate it, flip the exponent, and solve. That is all. So this is being raised. Anything in the parentheses is being raised. So this negative 2 is not. So I have to divide by the negative 2. Okay, once I divide by negative 2, remember it's keep, change, flip, so it just should be positive 1 over 81, or you could just do it in your calculator and all is well. Now we flip our exponent, negative 3/4. Remember, keep the sign, it stays the same. That goes away, and we're left with x minus 29 equal, which is 27. Is this even? Yes, it is. Right here, I put the plus or minus. So it's x minus 29 equals 27. And x minus 29 equals negative 27. And we solve. So x equals 56. And x equals 2. And then take a second and check. All right, so that works. Check, check. Awesome. All right, now try this one on your own. We'll see how you do. All right, so this is what it should look like, I hope. You saw this. What is being raised to the negative 3rd power? Well, it is just that x. Okay, there's no parentheses or anything, so I have to get rid of the 2, get rid of the 3, flip the exponent. It's not even. It's odd, so it's just 1/3, and it checks. Perfect. All right, finally we have our last question one. Okay, this one's a little bit more involved, so I want to make sure you understand. When I isolate that x, this radical, which we could write, and probably is a good idea, to write x, that whole 15 minus 7x to the 1/2 power. When we subtract this one, we have to, we can't combine them. So we have to flip the exponent, square both sides, 2 over 1, however you want to think of it. This goes away, and I'm left with 15 minus 7x. And then when I square this guy, okay, remember that's like the box method, x minus 1 times x minus 1. And when I do that, I get x squared minus 2x plus 1. Okay, and now it's a quadratic. So when we have a quadratic, we must set it equal to 0. Unless it's just x squared all by itself, we have to get it set equal to 0 first. So I get x squared minus, or plus 5x minus 14. Solve this guy. So I get x equals negative 7 and x equals 2. Now I should check those to make sure that they work. So take a second and check. All right, when I checked this one, it turned out that negative 7 didn't work, because when I plugged it in, I got positive 9 on this side and negative 7 on this side, so that doesn't work. And then when I do plug in the 2, that one works just fine. So the only answer is 2. All right, have a good one.